Good day, learners. It's nice to meet with you once again. Today, we'll be looking at metallic substance, and this one is channel. We've talked about covalent compounds, talk about covalent bonds and substances. So today, we'll be looking at metallic substance. I know you're familiar with what metallic substances are. Things like your iron, silver, gold, um, copper, and the likes. Okay, so metals generally are metallic. Okay, and generally metals are substances that ionize by losing electrons. So it means electrons are embedded in metals. Okay, so over 3/4 of all the elements on the periodic table are metallic. Okay, so metals generally have this giant structure, giant lattice structure, arranged in a regular pattern. So, and the outer shell electrons of metals are delocalized. What I mean by delocalized is they are mobile, they can move. Okay, they are free to move in every part of the structure of this metal. This ability to move, or this delocalization of the electrons of metals, is responsible for their electrical conductivity. So that's what makes metals good conductors of electricity. So if you are in any time asked why a particular substance conducts electricity, the answer is simple. It's because that particular substance have delocalized electrons in its structure. Okay. In fact, to delve or to divert to what we treated the last 3 lessons, on this channel, when we treated graphite and diamond, you would notice we said graphite can conduct electricity because graphite has delocalized electron. In fact, graphite is the only form of carbon, a non-metal, that can conduct electricity because of this unique feature that it has. So when you look at the bird, you will see the structure of the metallic bond. You can see those tiny, tiny round balls. They are the free electrons from the outer shell of the metal. Okay. The nucleus is positive. Okay. And then they have outer electrons. Okay. That are delocalized. So, of course, there's a strong attraction between this positive nucleus, okay, of this atom, and, of course, the delocalized electrons. So this attraction between the nucleus and these electrons is what is called the metallic what? Bonding. Okay. You would recall when we treated atomic structure, okay, we said electrons are negatively charged, okay, and the net charge of your nucleus is positively charged. So there's always this attraction between electrons and the nucleus of an atom. So in the case of metal, we have, of course, positively charged nucleus, and there's an attraction between this charge and the delocalized electrons. Okay, and that is known as your metallic bonding. Okay, and since this attraction is strong, okay, it makes metallic bond a very strong bond. Okay, and this is responsible for its high melting point. Okay, when a bond is strong, it will be very difficult for one to break that bond. So you need higher temperature for that compound or that metal to melt. Okay, for example, you can say aluminum has a melting point of about 660 degrees Celsius, while iron, on the other hand, has about 1,500 to 2,000 degrees Celsius. Okay, so I've talked about their electrical conductivity. Metals generally are good conductors of electricity because of the presence of the localized electron that can move through the structure, carrying the electric charge, okay, through the metal. Thermal conductivity is also the same reason. These electrons have the ability to move or carry, heat from one point of a metal to another. In fact, that is why heat transfer by conduction is mainly possible in metals. When you hold the tip of a iron bar and you introduce the other end to heat or fire, and you hold the extreme end. Over time, you start feeling the heat from the point you were holding it. And it will get to a point where you're not able to hold it with your bare hands anymore. Because by then, so much heat would have, traveled from one end of the metal to where you are. And that is made possible by electrons. You have your rod here, and then you have your fire here. Okay. This iron rod is a metal. So this metal has what we call delocalized electrons. So this E represents your electrons. So immediately they come in contact with heat or electricity. The electrons, they are mobile. They'll be moving towards that direction, towards where you are holding it. Okay. And when it gets to this point, you feel the exact heat. Okay. Feel the heat. And that is how the electrons will be, moving until this whole point will get almost as hot as the tip that touches the fire. Okay, so that is thermal conductivity. Malleability. Metals are generally malleable, which means they can be beaten into shape, into various shape. Okay, this is because they have layers of atom that can slide over each other. Okay, like sheets arranged on each other that can slide over each other. So I want you to take note of these basic properties and the reason why they behave so. Number one, metals conduct electricity and heat because of the presence of delocalized electrons in their structure. Okay. So that is the reason for that. And secondly, for malleability, they are malleable because they are made of layers of atoms that can slide over each other. So these are very, very important for us to note. Okay, so we will draw the curtain here today to be continued when next we meet. Thank you once again for tuning in to our channel. Don't forget to subscribe, hit the subscribe button, like, and share. Okay, so that your friends can also benefit from this lecture. Okay, so meet again. Bye.